We are Gator Blacksmithing from the University of Florida, and we're excited to be making our comeback in the TMS Bladesmithing competition. Our blade of choice was a Bowie knife, named after frontiersman Jim Bowie, who famously used one when a fight broke out following a duel in 1827. We also used a pattern welded Damascus steel design, which originates from southern India and Sri Lanka. While our design team drafted some beautiful plans, we decided that with our limited forging equipment, it was best to choose a simpler design. We began by cutting 6 plates each of 1084 and 15N20 steel, chosen for their respective hardness and toughness, as well as their visual contrast when etched. We alternated these metals in our billet with the goal of creating a striped Damascus pattern, then tacked the layers together via welding. We also welded a temporary handle to the billet so we could easily sand it with the belt grinder, and move it in and out of the forge without tongs. To combine the steel plates, we needed to forge weld the billet. This involved heating the piece to a glowing orange, then hammering it down until the layers fused. We applied borax periodically to react with and clear away oxides that may have formed between the plates, making it easier to forge weld them together. Unfortunately, the temporary handle proved more temporary than expected. We believe the billet overheated while we tried recovering it with tongs, partially causing some delamination. We tried to cut off the affected plates and carry on, but the billet cracked during forging a few days later. We restarted with a new billet, this time fully welding the sides to prevent oxide formation between the plates. This forge welding attempt succeeded, and we were able to begin forging the blade itself. The first step was to draw out the length of the blade. 2 strikers alternated hitting the workpiece to deform the metal as much as possible before it cooled. Proper communication was necessary to ensure that our team operated efficiently and safely, so we coordinated our movements around the forge and called out our destinations whenever we were transporting hot metal. We used the strike setting technique to apply precise blows, with one smith holding a flatter in place while a second smith struck with a hammer. The flatter would more equally distribute the force across the blade surface and even out the thickness. We forged out the knife's tang using a fuller to indent either side of the piece, then flattening and drawing out the tang. Once the blade and tang had been drawn out to the right dimensions, we heated the workpiece one last time in the forge and allowed it to air cool, relieving some residual stresses induced by forging. We drew the blade's outline, then removed excess material and shaped up the blade with a belt grinder. The cutting edge was left thicker than a standard Bowie knife to comply with TMS and University of Florida standards. While this should have shortened the grinding process, it still took a very, very long time. As we moved into heat treatment, we wanted to see if the temperatures and times we researched would have the intended effects on the microstructure and material properties of our blade. To do so, we used 4 samples taken from the first billet to obtain scanning electron microscopy images at each step of the process, followed by Vickers hardness testing. The blade was first normalized above its austenitization temperature and air-cooled to reduce internal stress gradients. We then heated it to 900 degrees Celsius for roughly 90 minutes, followed by a Gatorade quench, cooling the FCC austenite into BCT martensite. This greatly increased hardness at the cost of introducing internal stresses. To resolve this, the blade was tempered at 225 degrees Celsius for 1 hour to produce tempered martensite, leading to a more balanced combination of hardness and toughness suitable for a knife application. We began hand sanding the blade to remove scratches and imperfections, but started noticing small surface cracks and decided to bake it again at 230 degrees Celsius for 1 hour to relieve stresses that may have caused the cracks to form. We then hand sanded again up to 3000 grit, resulting in a smooth, mirror-like surface finish. The blade was etched using boiling vinegar, a mildly acidic etchant that would oxidize the surface and bring out the contrast between the 2 types of steel. It was periodically removed for light sanding to control the depth of etching and remove the formed oxide layers. Our second etchant was an unappetizing solution of strong coffee and vinegar, further darkening the surface and improving contrast. The blade was then buffed using a polishing wheel to get a clean, uniform finish. The final step was assembling the handle. 2 blocks of ironwood were selected and milled out in the shape of the tang. The pieces were superglued together, then filed and chiseled down for an ergonomic fit. We applied linseed oil to provide moisture resistance and make the natural color stand out. And with that, GatorFang was complete. This has been a very exciting project for us, and we've learned a lot along the way. Thank you for watching, and go Gators!